La 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 la. All right, that was my sound check. We want to talk a little bit, before we get into free body diagrams, we want to talk a little bit about forces. Forces. So by now we've all seen Newton's second law, which states F equals, let's see, let's make an equal sign. There we go. F equals ma. This is usually in vector. Well, sometimes in vector form, sometimes in scalar form. Properly it's a vector because force is a vector. It has a direction and magnitude. Acceleration is a vector, direction and magnitude, and then mass is a scalar. Of course, there is no vector mass. But we do often, if we're working in one dimension, we will sometimes write the scalar form. But anyway, you've all seen Newton's law. So I'm going to just give you a little brief here about what different kinds of forces you can see, what forces will happen, what kind of forces you're likely to run into, at least in the beginning of this of our unit of forces. So let's say we have a box here that's sitting on the ground, and there we go, and there's the ground, and we have a person pushing on the box. So this person is pushing on the box like so. Maybe putting some real effort into it. Well, maybe I don't know, like there we go, like that. So really pushing on the box. So what are the forces we've got acting on the box? Well, let's let's start with a couple of sort of basic forces that we have on almost everything. One of those is the weight. So you can draw the weight at the center of the box if you like. So force number one, I'm going to say weight. The weight is the force gravity acting on the box. So that can be abbreviated W. Sometimes it can be F sub g, force due to gravity. Sometimes it's just m times g, written as mg because it's mass times gravity, right? So, and these are all vectors. G is a vector. So the weight is one of our common forces, always acts downward, always acts toward the center of the Earth. When we're on the Earth, if obviously we're doing like an orbital mechanics problem or something, it might be different, but basically this is what it amounts to. So if the object is just sitting on the ground, it's not burning a hole through the ground to go to China or wherever, go to the center of the Earth, obviously something's stopping it. Well, the ground is pushing back on the object. So that is called, let me get through that, there we go. That is called the normal force. Normal force pushes upwards. So normal force. This is sometimes written, just N. Sometimes it's written F sub N. Some people, consider N just fine, capital N just fine. Some people consider it to be sacrilege of the highest order to represent a force with the letter N, so they would use F sub N. Your choice. The normal force always acts perpendicular to the surface that's exerting it. In fact, the word normal in math frequently means perpendicular. So in math, for example, if you have a, I'll just go back to black here for a second. If you have a curve doing something like this, and you pick a point, say right here, and you want to examine directions relative to that point, this direction is called the tangent. We all know that, tangent of the curve. But interestingly enough, this direction is called the normal. So sometimes that'll be represented with a little vector n, and then the tangent, of course, will be a vector t, something like that. So normal, that's where the word normal comes from. They're not saying, this force is perfectly normal, nothing to see here. That's not what it means. It means, it's perpendicular to the surface that's causing it. That's exerting the normal force. So that's important to remember. Now, another force that comes along with the normal force is the force due to friction. Friction is interesting because friction happens at a contact where there's a normal force, and friction occurs perpendicular to the normal force. So, for example, if this block was moving, say, velocity was greater than 0 and it's going that way, so this guy's pushing it, then friction would be acting down here and pointing that way. So F sub F is how I typically write friction. I'm just going to put labels on all these so that you can see what they are. And it's the normal force, weight, friction. Friction force is there. And that is, some people will write that as like a script F. So something like that. I'm not really good at doing like cursive and stuff like that, so I just do F sub F. And I'm one of these horribly inconsistent people who does like F sub F here, but then I'll do the N for normal force. So because I'm just a rebel. I don't play by any consistent set of rules. I just throw random stuff at you. So there's some forces. What's another force that is acting on the box? Well, this dude is pushing it, right? That was the whole point of the problem. So let's pick yet another color. How about this peachy color? Sort of, yeah, well, that's a little too much like pink. And by the way, I really do think this pink is kind of disgusting, but apparently some people like it and take offense when I say it's a disgusting pink. So anyway, let's say this brown. Yeah, this brown looks too much like black too. So let's go with, I don't know, teal. Yeah, there we go. Teal is always a good color. Oh yeah, that's gross. Okay, so this force is just being exerted by the guy, pushing. So you can say really what it is, it's another kind of normal force. We don't usually refer to this as the normal force. By normal force we usually mean the ground, but it is a normal force because it's a contact force. This guy is pushing. Force from, pushing, you can call it that. And I'm just representing that as F. I'll say F, I'll call that F sub 1. Whoops, let's see. F sub 1 and say, this guy is, we're going to label him 1. Just call him that. And hold on a second. Someone's coming in. Alright, I'm back. That's just lab equipment coming in. So, let's see. What else did I want to talk about? So, let's, and the interesting thing about this pushing force, by the way, is that you can't pull with a normal contact. You have to push. There's no way, if you think about it, there's no way this guy, just by slapping his hand against this surface, could pull on it. So that's what I call one of Smith's laws, and I'll talk about those in a second. So the other final force I want to talk about today, let's do this sort of, this color, there we go. So actually, before I do that, let me draw someone else in the problem. Let's say there's another guy here, and he's got a rope attached to this crate, and he has something slung over his shoulder, and so he's doing this, and it's like his arms grabbing the rope, and he's pulling on it, and say that's guy number 2. Guy number 2 is pulling on this rope, like that. So the force the rope is exerting on the crate, we usually call that tension. So let me try sort of a dark purple color. There we go. And T. So finally, tension. And that's sometimes done with T, or sometimes F sub T, or just, some other F sub something else. Tension sometimes, it's a special letter. Sometimes it's just treated as some other, F. So these are really sort of the 5 forces you'll see most often in these kinds of problems. You'll see, well, let me do, yeah, fine. Weight. You'll see normal forces. You'll see friction forces. You'll see pushing forces, and you'll see tension. The 2 rules, well, actually 3 rules to remember. Actually, each of them has a rule, really. Weight. So let me just summarize these below and give you some rules to apply to them. One is weight, and always acts down in the direction of gravity. All right. Normal force is always perpendicular to the surface of contact. So normal force is always perpendicular to the surface of contact. Let's see. Contact. There we go. All right. Number 3. Actually, the other thing about the normal force is that the normal force can only push. Number 3 is that the friction force always acts against the direction the objects are moving. Always acts against a slip. So if you have two objects and they're like this, say they're stacked up like that, and one is moving this way and one is moving this way, then the friction is going to be pulling on this one this way and this one this way. It's always going to act against the direction things are slipping. And I have I'm just about time, but let me get a little more in. Number 4, pushing. Actually, that's just another normal force. That's like normal force, so I'll leave that out. But number 5 is tension. Tension, tension always pulls. You cannot push with a rope. It's sort of semi-obvious to say that, but frankly, it's the sort of thing you can forget when you get deep into a problem and you're working on it, and you get a negative number out for tension, but you don't realize, you don't remember it's negative, you don't remember which direction it's supposed to go, whatever. You always need to have tension be pulling, normal force pushing, friction acting against the slip, and weight going downwards. Those are the rules, and if you remember them, you'll be in pretty good shape.